In this series, we will discuss different topics associated with sports nutrition and weight management. But today in particular, we will discuss the topic carbohydrates and its role during exercise. So carbohydrates are macronutrients and are one of the three main ways by which our body obtains its energy. They are called carbohydrates as they comprise carbon, hydrogen and oxygen at their chemical level. Carbohydrates are essential nutrients which include sugar, fiber and starches. They are found in grains, vegetables, fruits and in milk and other dairy products. They are the basic food groups which plays an important role in a healthy life. So, the food containing carbohydrates are converted into glucose or blood sugar during the process of digestion by the digestive system. Our body utilizes this sugar as a source of energy for the cells, organs and tissues. The extra amount of energy or sugar is stored in our muscles and liver for further requirement. So basically, what is carbohydrates? So the term carbohydrates is derived from a French term hydrate de carbone, meaning hydrate of carbon. The journal formula of this class of organic compound is CnH2O bracket and N. So carbohydrates are also known as starchites or carbs, provides energy for the body. Each gram of carbohydrates provides 4 calories. The body breaks carbohydrates down into glucose, which is the primary energy source for the brain and muscles. Carbohydrates are one of 3 macronutrients, which are nutrients that the body needs in larger amount. The other nutrients are protein and fats. Protein provides 4 calories per gram and fats provide 9 calories per gram. So how are carbohydrates digested? So carbohydrates are digested in the small intestine. They are broken down into simple sugars such as glucose and fructose. These sugars are absorbed into the bloodstream and can be used for energy. Some sugar is converted to glycogen and stored in the liver. Between meals, liver glycogen is converted back into blood glucose as an energy supply. Glycogen is also stored in muscles for muscle activity. Carbohydrates not used for energy or glycogen stored are converted into fats. So this is the classification of carbohydrates. The carbohydrates are further classified into simple and complex, which is mainly based on their chemical structure and degree of polymerization. So carbohydrate is divided into 2. One is simple and another one is complex. The simple is further divided into 2, monosaccharides and disaccharides. In monosaccharides, there are glucose, fructose and galactose, and saccharides includes maltose, lactose and sucrose. In complex, there is polysaccharides, which comes starches, fibers and glycogen. So what's the difference between simple and complex carbohydrates? So a food's chemical structure and how quickly your food digests it determines whether the food is a complex or simple carb. Complex carbs are less likely to cause spikes in blood sugar. They also contains vitamins, minerals and fibers that your body needs. You may be familiar with the term good carbohydrates, but it may be best to think of them as healthy carbohydrates. Too many simple carbs can contribute to weight gain. They can also increase your risk of diabetes, heart disease and high cholesterol. Simple carbohydrates, which is monosaccharides, disaccharides and oligosaccharides. Simple carbohydrates have one or two sugar molecules. In simple carbohydrates, molecules are digested and converted quickly, resulting in a rise in the blood sugar level. They are abundantly found in milk products, beer, fruits, refined sugars, candies, etc. These carbohydrates are called empty calories as they do not possess fiber, vitamins and minerals. So let's start with monosaccharide, which is one of a simple carbohydrates. So monosaccharides are single unit of sugar. Example includes glucose, the body's main source of energy. Then galactose, which is most readily available in milk and dairy product. Then fructose, which mostly occurs in fruits and vegetables. Then disaccharides are two, now we will talk about disaccharides, and disaccharides are two sugar molecules joined together. Example include lactose, found in milk, which is made up of glucose and galactose, sucrose or table sugar, which is made up of glucose and fructose. Now let's see complex carbohydrates. So complex carbohydrates have two or more sugar molecules, hence they are referred to as starchy foods. In complex carbohydrates, molecules are digested and converted slowly compared to simple carbohydrates. They are abundantly found in lentils, beans, peanuts, potatoes, peas, corn, whole grains, bread, cereals, etc. So polysaccharides are complex carbohydrates formed by the polymerization of a large number of monomers. Example of polysaccharides include starch, glycogen, cellulose, etc., which exhibit extensive branching and are homopolymers made up of only glucose units. Now polysaccharides are chains of many sugars. They can consist of hundreds of or thousands of monosaccharides. Polysaccharides act as food stores for plants and animals. Example includes glycogen, which stores energy in the liver and muscles, starches, which are abundant in potatoes, rice and wheat, then cellulose, one of the main structural component of plants. Now let's see the sources of carbohydrates. Simple sugars are found in the form of fructose in many fruits. Galactose is present in all dairy products. Lactose is abundantly found in milk and other dairy products. Then maltose is present in cereal, beer, potatoes, processed cheese, pasta, etc. Then sucrose is naturally obtained from sugar and honey containing small amount of vitamins and minerals. Now let's see what are starches. So starches are complex carbohydrates. Many starches, but not all, fit this category. They provide vitamins and minerals. It takes your body longer to break down complex carbohydrates. As a result, blood sugar levels remain stable and fullness lasts longer. You can find starchy carbohydrates in beans, legumes such as black beans, chickpeas, lentils and kidney beans. In fruits such as apple, berries and melons. Whole grain products such as brown rice, oatmeals, whole wheat breads and pasta. In vegetables such as corn, lime beans, peas and potatoes. Now let's see what is fiber. So plant-based foods such as fruits, vegetables and whole grain products contain fiber. Animal products including dairy products and meat have no fiber. So fiber is a complex healthy carbohydrates. Your body can't break down fiber. Most of it passes through the intestine, stimulating and aiding digestion. Fiber also regulates blood sugar, lower cholesterol, and keeps your feeling full longer. So experts recommend that adults consume 25 to 30 grams of fiber every day. Most of us get half that amount. High fiber foods include beans and legumes such as black beans, chickpeas, lentils and pinto beans. Then fruits, especially those with edible skins like apple and peaches, or seeds, berries. Nuts and seeds including almond, peanut, walnut, pumpkin seeds and sunflower seeds. Whole grain products such as brown rice, oatmeal, quinoa, cereals and whole wheat bread and pasta. Vegetables such as corn, lima beans, broccoli, Brussels sprouts and squash. Now what are sugars? So sugars are a type of simple carbohydrates. Your body breaks down simple carbohydrates quickly. As a result, blood sugar levels rise and then drop quickly. After consuming sugary foods, you may notice a burst of energy followed by feeling tired. Sugar goes by many names. On food labels, you may see sugar listed as agave nectar, cane syrup, or corn syrup, dextrose, fructose or sucrose, honey, molasses, sugar. So the American Heart Association recommends no more than 25 grams or 6 teaspoons or 100 calories per day of adding sugar for most women, no more than 36 grams or 9 teaspoons or 150 calories per day of added sugar for most men. Now let's see what is the recommended daily amount for carbohydrates. So there is not a set amount of recommended daily carbs. Your age, gender, medical conditions, active level and weight goals all affect the amount that's right for you. So counting carbs helps some people with diabetes manage their blood sugar. You should fill half your plate with fruits and vegetables, 1/4 of your plate with whole grains, 1/4 of your plate with protein like meat, fish, beans, eggs or dairy. Now let's see what is glycemic index. So the speed at which the carbohydrates in a food are digested to glucose is called the food's glycemic index value. So the low GI foods are broken down slowly. The glucose or energy from their carbohydrate is released into the blood over several hours. Low GI foods prolong digestion due to their slow breakdown and may help with you feel full for longer. So high GI foods are digested rapidly and give you a blood glucose spike. Slow digestion is better than fast digestion. So low GI foods are generally better than high GI foods. This is important if you have diabetes. It helps keeps your blood glucose level stable. Now let's see what are the functions of carbohydrates in our body. So carbohydrates are an essential part of our diet. Most importantly, they provide the energy for the most obvious functions of our body, such as moving or thinking, but also for the background functions that most of the time we do not even notice. During digestion, carbohydrates that consist of more than one sugar get broken down into their monosaccharides by digestive enzymes and then get directly absorbed, causing a glycemic response. So the body uses glucose directly as energy source in muscle, brain and other cells. Some of the carbohydrates cannot be broken down and they get either fermented by our gut bacteria or they transit through the gut without being changed. Intestinally, carbohydrates also play an important role in the structure and function of our cells, tissues and organs. Now, carbohydrates as energy source and their storage. So, this is one of the most important function of carbohydrates. So, carbohydrates broken down to mainly glucose are the preferred source of energy for our body, as cells in our brain, muscles and all other tissues directly use monosaccharides for their energy needs. So, depending on the type, a gram of carbohydrates provide different amount of energy. Starches and sugar are main energy providing carbohydrates and simply 4 kilocalories per gram, and pulses provide 2.4 kilocalories and thus gives you 0 calories. Dietary fibers 2 kilocalories per gram. Now, monosaccharides are directly absorbed by small intestine into the bloodstream, where they are transported to the cell in need. Several hormones including insulin and glycogen are also part of the digestive system. They maintain our blood sugar level by removing or adding glucose to the bloodstream as needed. So, if not used directly, the body converts glucose to glycogen. Polysaccharides like starch, which is stored in the liver and the muscles as a readily available source for energy. When needed, for instance, between meals, at night, during sports or physical activity or during short fasting period, our body convert glycogen back to glucose to maintain a constant blood sugar level. The brain and the red blood cells are specially dependent on glucose as energy source and can use other forms of energy from fats in extreme circumstances, like in very extended period of starvation. It is for this reason that our blood glucose must be constantly maintained at an optimal level. Approximately 130 grams of glucose are needed per day to cover the energy needs of the adult brain alone. Now, the second one is the glycemic response and glycemic index. So, when we eat a carbohydrate containing food, blood glucose level rises and then decreases, a process known as a glycemic response. It reflects the rate of digestion and absorption of glucose as well as the effect of insulin in normalizing the blood glucose level. So, a number of factors influence the rate and duration of the glycemic response. The food itself, the type of sugar or the form of carbohydrates. For example, fructose has a lower glycemic response than glucose, and sucrose has a lower glycemic response than maltose. So, the structure of the molecule, for example, a starch with more branches is more easily broken down by enzymes and therefore more readily digestible than others. The cooking and processing method used, the amount of other nutrients in the food such as fat, protein and fiber, then the metabolic or circumstances in every individual, the extent of chewing, mechanical breakdown, the rate of gastric emptying, transit time through the small intestine, which is partly influenced by the food, metabolism itself, the time of day the food is ingested. So, the impact of different foods as well as the processing techniques of the food on the glycemic response is classified relative to a standard, usually white bread or glucose. within 2 hours after eating. This measurement is called the glycemic index. So the AGI of 70 means that the food or drink caused 70% of the blood glucose response, which would be observed with the same amount of carbohydrates from pure glucose or white bread. However, most of the time carbohydrates are eaten as a mixture and alongside proteins and fats, which all influence the GI. High GI foods causes a greater blood glucose response than low GI foods. At the same time, foods with a low GI are digested and absorbed more slowly than foods which have a high GI. There is a lot of discussion on in the scientific community, but currently insufficient evidence to suggest that a diet based on low GI food is associated with a reduced risk of developing metabolic diseases such as obesity and type 2 diabetes. Now we can see the glycemic index of some common foods. So foods with a very low GI is raw apple, lentils, soya bean, kidney beans, cow milk, carrot or barley. Then food with low GI with 41 to 55, noodles and pasta, apple juice, raw oranges, dates, raw banana, yogurt, whole grain bread, strawberry, jam, sweet corn, chocolate. Then food with an intermediate GI, which is 56 to 70, brown rice, rolled oats, soft drinks, pineapple, honey, sourdough breads. Then food with a high GI, which is white and whole meal bread, boiled potatoes, cornflakes, French fries, mashed potatoes, white rice, rice crackers. So these were the GI food index. Now gut functions and dietary fiber. Although our small intestine is unable to digest dietary fiber, fibers helps to ensure good gut function by increasing the physical bulk in the bowel and thereby stimulating the intestinal transit. So once the indigestible carbohydrates passed into the large intestine, some type of fibers such as gums, pectins and are broken down by the gut microflora, and this increases the overall mass in the bowel and has a beneficial effect on the makeup of the gut microflora. So it also leads to formulation of bacterial waste products like short chain fatty acids, which are released in the colon with beneficial effect on other health. Now, role of carbohydrates during exercise. So carbohydrates is an important energy source during exercise. During short, heavy exercise, it may be one of the energy source for the working muscle and may be derived exclusively from the glycogen stores with the muscle fibers themselves. During prolonged submaximal exercise, the magnitude of the contribution that carbohydrates make to the total fuel consumed depends upon a number of factors, includes the intensity of the exercise, the duration of the exercise, the state or type of training that individual has engaged in, or the diet previously consumed. Due to their limit storage in the body and the relative ease with which these stores can be manipulated by combination of diets and training. A knowledge of the dynamics of carbohydrates metabolism is an important component in the arsenal of knowledge for coaches and athletes. So let's see carbohydrates as a fuel for our muscles. So activities that involves a certain effort both to increase intensity, duration and muscle contraction. The source of energy is preferred by active muscles, and as it is provided by carbohydrate, it is very easy to deduce that in order to have optimal performance of the muscle, we must carry out a diet rich in carbohydrates. However, it is necessary to take into account the metabolization process of these to get the most out of the physical activity and exercise. Now, in what happen if it is a high intensity workout? As we have already mentioned in our workout that exceed a certain intensity, the glycolytic energy substrate is the most common. So, the goal will be to quick provide the necessary ATP that allows the muscle contraction at the rate that determines the intensity of physical effort being carried out. So, the three energy pathways through which it is produced are phosphagen system, activities with the highest intensity possible for shortest duration, and for example vertical jump, weightlifting, 100-meter race. Then glycolic system, activities of medium to high intensity and short duration, example CrossFit, pod or 400-meter race. Then the last one is oxidative system, the least efficient of all, considered for low intensity long duration activities, for example walking, cycling or gentle pace activities. Then carbohydrate before training, we are going to take a look at two different scenarios: training immediately after getting up, or if you had your last meal more than 3 to 4 hours ago, training after eating a meal. So, the most recommended approach nutritionally speaking before doing an intense workout would be have a meal with complex types of carbohydrates, moderate in its amount of protein, and although it may be low in fat, would be the good idea to include some from fat, taking into account the benefits it can provide such as coconut oil. And we should give our body time to digest this meal as the best it is possible, can maximizing gastric emptying and helping more nutrient to become available. Now, carbohydrates during training. In short sessions, it is better to limit yourself of water to obtain the best state of hydration possible and not to alter energy and biological process. In environments with adverse weather, it's recommended that you take electrolytes and make a type of sports drink, however you would prefer. So, carbohydrates after training, after your workout, once training is over, the organism goes through a period of accelerated supercompensation in which it tries to increase all the process for recover of lost energy. It is estimated that within the first 2 hours after finishing exercise, the body doubles the speed of glycolysis. So, at this time, the ideal is to provide high glycemic index carbohydrates that accelerate glycogen replacement. Now, we have come to conclusion. You may have been thinking of carbohydrates as either good or bad. As with all foods, the secret with carbohydrate is to make a smart decision and limit the ones that are not as healthy for you. Your best bet is to choose nutrient dense carbs that have fiber, vitamins and minerals. Eat food that have added sugar in moderation. Your healthcare provider can help determine the right amount of carbs for your need. And carbohydrates are an important source of energy for the body. Some types are more healthful than others. For instance, dietary fiber is a carbohydrate that protects your heart and gut health, whereas added sugar can lead you to increased risk of type 2 diabetes, heart disease and overweight. So, following a well-balanced diet that includes unprocessed carbohydrates and getting enough sleep and physical activities are more likely to lead to good health and a healthful body weight than focusing on or eliminating a particular nutrient. So, I hope you all understood about carbohydrates, its type, importance of carbohydrates in our body, sources of different carbs, and role of carbohydrates before, during, and after exercise. That's all for today. See you next time with some other interesting topic. Thank you.